discussed addition theorem on mathematical expectations. Just I'll tell you, we write the expectation of any random variable with e of x, and depending upon the type of the variable, if it is discrete, we'll start with sigma. Whatever we have in the brackets, we'll write that and its PMF. If it is a continuous variable, you'll start with integral, and within the brackets we have x, and we write the corresponding PDF. You know, this is the definition for expectation of x, or expectation of a random variable. Also, we have discussed the addition theorem on mathematical expectation. Now we are going to discuss the multiplication theorem on random variables. So the statement is, for any two independent random variables. In addition theorem we wrote for any two random variables, but in multiplication theorem we are writing in specific that for any two independent random variables, e of xy is equal to e of x into e of y. When the multiplication theorem is valid only when the given variables are independent. So addition theorem is for any two variables, but multiplication theorem is only for independent variables. So let us do the proof here. Let x comma y be a bivariate random variable with PDF. I think we write the joint PDF with f of x comma y, and marginal PDF of x with g of x, marginal PDF of y with h of y. So you know that formula for g of x is f of x comma y dy. For h of y it is f of x comma y dx. Okay. So let f of xy be the joint PDF, g of x be the marginal PDF of x, h of y be the marginal PDF of y. We know the formulas for g of x and h of y. What you need to prove? You need to prove that e of xy is equal to e of x into e of y when x comma y are independent. When they are independent only we can prove this. So we have already proved that whenever the variables are independent, f of xy is equal to g of x into h of y. So this is the case when x comma y are independent. F of xy is equal to, we know that joint PDF is equal to product of the marginal PDFs when they are independent. So e of xy, how can you write this as you have two variables, you should start with two integrals. Within the brackets we have the product xy, so write down the same, and it's as you have two variables, write down the PDF. Again I repeat, you need to prove e of xy is equal to e of x into e of y. For that I have considered the LHS, which is nothing but e of xy. E of xy is equal to, as you have two variables, we start with double integral. So you have with whatever you have in the brackets, you should write the same xy into the joint PDF f of x comma y dx dy. Now as x comma y, what is given in the statement, x and y are independent. So whenever x and y are independent, we know that f of xy can be replaced with the marginal PDFs, product of the marginal PDF, g of x into h of y. So e of xy becomes double integral xy into g of x into h of y dx dy. So I want to write this as x g. I want to separate x terms and y terms. So this is nothing but e of x. You know that this stands for e of x, and the other term stands for e of xy. So e of xy is equal to e of x into e of y when x comma y are independent. This is the multiplication theorem on mathematical expectations. So I am going to do certain results on expectations. Like the first one, expectation of a constant is constant. Okay, all these are short answer questions. or by combining two, that may be a long answer also. That is, if C is constant, you need to prove that E of C. So expectation exists only for the variable whenever it's a constant. Expectation of a 2 is 2, expectation of 3 is 3. For any constant in general, if C is any constant, E of C is C. So how can you write E of C? If it is a continuous variable, I think you will start with C. Within the brackets we have C, and you should write the PDF as not the PDF of C. For a constant there won't be any PDF. Only for variables there will be a PDF. So within the brackets we have C. I wrote C. PDF means always that is for only variable. So f of x dx. So you know that C is a constant. You are integrating with respect to x. So C can be taken out, f of x dx. I think you know that as this is a PDF, this entire total probability is 1. So C into 1. So expectation of C is nothing but C. That is, expectation of a constant is constant. Second result is nothing but expectation of Ax is equal to A into expectation of x, where A is a constant. Whenever we have expectation of 2x, expectation of 3y, it becomes 3 into expectation of y. So let us consider expectation of LHS, expectation of x. So if it is a continuous variable, as we have only one variable and it's a constant, you will start with integral. Within the brackets we have Ax, you will write the same, and you will write the PDF of x, which is nothing but f of x dx. Again, this a can be taken out as it is a constant, x into f of x dx. Okay, we know that how much you got? Expectation of Ax is equal to a into x f of x dx. So this is, what is the formula for E of x? E of x is nothing but integral f of x dx. So we got a expectation of Ax is equal to a into expectation of x. So what from this, what will be expectation of 2x? 2 into expectation of x. What will be expectation of 3y? 3 into expectation of y. This is the second results. So let us go to the third result. Like, you need to prove that expectation of Ax plus b is equal to a into expectation of x plus b. Okay, so consider the LHS. What is E of Ax plus b, where a comma b are constants. X is the only variable and a and b are variables. A and b are constant. As you have only one variable, you will start with integral. Within the brackets we have Ax plus b, and you should write the corresponding PDF f of x dx. So it is Ax into f of x dx plus b into f of x dx. Let us separate the integral. So integral Ax f of x dx plus b integral f of x dx, as b is a constant. When a is taken out, what is integral f of x dx? This value is 1. This is nothing but expectation of x. So a into expectation of x, which is nothing but RHS. So the third result is also proved. So from this, how can you write expectation of 3x plus 5? We can write that as, this is a and this is b. 3e of x plus 5. Okay. Similarly, these are the some results on if they asked to find out expectation of 3x plus 3y. How can you do this? As 2 and 3 are the constants, expectation of 2x, you know that using the addition theorem on expectations, E of x plus y is nothing but E of x plus E of y. So that will be E of 2x plus E of 3y. As 2 is a constant, 2 into expectation of x plus 3 into expectation of y. This is nothing but using addition theorem. So these are the certain results on mathematical expectations. Okay, thank you.